This is the lecture for your topic 9.4. It will go with your assignment number 21. It's over solving equations that have radicals in them. So equations with radicals. So what we've been learning so far in the topic 9 material is that radicals and exponents are inverse operations of each other. And so when you have a radical in an equation, you're trying to solve for x, you're going to want to isolate the radical on one of the side of the equation. It doesn't matter which side, just make sure the radical is like by itself. In this case, that's already by itself on the left-hand side of the equal sign. If you look at example 50, it's not. We have a radical and then a plus 1. So we would have to move the plus 1 over. So you're kind of treating it like it's the term that has the variable, and you're just trying to isolate that first. And then the second thing you will do is raise both sides of the equation to the same power as the index. What that does is that eliminates the radical. It cancels it out. Again, because if I were to say, basically like the square root of 2, and if I raise that to the second power, that's like taking it times itself, and it cancels it out. In a long form, let's say you were actually multiplying that together. The square root of 2 times the square root of 2 would be the square root of 4, which really just gives you 2, okay? And so instead, we don't have to think of it like that. When you take this square root, and if you just raise it to the second power, because the understood index is a 2, then the square root right here and the exponent cancel each other out, leaving you with just 2, with a 2 underneath, instead of having to go through all those steps, okay? If it were a cube root of 2, we would raise it to the third power, and the exponent cancels the radical, leaving you with just the 2. Okay, so what that's saying is you're multiplying that times itself 3 times, which you made a perfect cube number, and then when you simplify it, it is just the number, the radicand that's under the radical. So it's undoing it, it's the inverse operation. And then you would solve, if it's a quadratic equation in the end, you would have to factor to solve like we had in previous examples. One thing about this section is you do have to check your answers every time, because there are times that when you plug the solution back in, it doesn't really work. And that's just because of how radicals work with positive and negative signs. And so that would be called or said to be an extraneous solution, but in WebAssign, you would just say no solution. Now, sometimes there's 2 solutions and one solution works and the other doesn't. So you would just say that, x equal 2 and maybe not 4. But let's say, you just had x equals 2, you plugged 2 in, it didn't work, then that would be a no solution answer. So I think we'll come across some of those examples whenever we go through our notes today. So since this radical is isolated, and since it is a cube root, we're going to raise this to the third power. Remember, what you do to one side of an equation, you do to the other. So we're raising that other side also to the third power. So the reason we do that is because this exponent cancels this radical, leaving the term that's underneath the radical as just for x, that radicand. And then we take -2 to the third power is a -8. Remember, you could plug that into your calculator. I would always, just out of good habit, I would always keep my number in a parentheses, just because there are some weird things that happen with even indexes and signs when you raise it to a power. It's just good habit to know when you're taking the negative with the multiplication and when you're not. And then we would divide by 4. So x equals a -2. So again, you have to check it every time. It doesn't tell you to. You have to know with equations with radicals, one of the steps in the solving is to check the solution. So we would say the cube root of 4 times, we said -2 equals 2. We have to see if that is a true statement. So we know that underneath that radical, 4 times -2 is -8, and then you could plug that into your calculator. Technically, I guess you could have plugged it in at this step. I just like to not rely on my calculator if I don't have to sometimes, and do some of the math without. So remember, if you're doing a cube root, you type in the number 3, second, and then the x square root button, and it brings it up to make it a cube root. And you can type in -8 and click enter, and that is -2. So -2 does equal -2, so that is a real solution of that equation. So again, we kind of already said this whenever we're reading the rules about solving equations with radicals, is that we want to isolate this radical. So we want to move this number over. Since it's a positive 1, we would subtract 1 first. So we have the square root of 10x plus 4 equals 9 minus 1 is 8. And so again, since you don't see an index, there's an implied 2 there. It's a square root. If you need to see it, go ahead and write it. Then you would raise it to the second power to undo the square root. So what that does is it's kind of like by doing that, you're pulling all of this that's underneath the radical out from underneath it. It cancels out that radical symbol. So you have, I'm going to come over here and write it, 10x plus 4 equals 8 squared is 64. So kind of worked to the left that time. That way I have some room over to check myself when we are done. So then we would just treat it like a normal equation. We try to get our x by itself. So we have 10x equals 60, divide by 10. So x equals 6. So again, before we say, hey, x equals 6, let's go ahead and check to see if that is true. So we take our square root, we're taking 10 times 6 plus 4 under the radical. Sometimes I like to put a little down at the end of the radical, so I know that's where that radical is ending. You don't have to. Plus 1 equals 9. Because it is important, if you plug it into your calculator like that and you're not doing the math underneath, like that's what I would do. I know 10 plus 6 is 60 plus 4 is 64. Plus 1, and the square root of 64 is 8 plus 1, which equals 9. So that would be a true solution. But if you're plugging it into your calculator, make sure you can use just the square root button, so second and the square root button right here, because we don't have to put the 2 in there. And so 10 times 6 plus 4, but because this is outside of the radical, you would have to arrow over so that you're not saying plus underneath that radical symbol. And so see how there's not a line continuing after that radical symbol. So that's kind of showing that it would be taking this right here, which ended up being the square root of 64 plus 1 to get that answer. Example 51, again, the first thing we would need to do is move that 9 over, so I'd be subtracting 9. So I have the square root of 4x minus 3 equals -5. So after I have isolated that radical, we wanted to get this by itself, because it's the term that has the radical symbol. I want to get it by itself on one side of the equal sign. After I've done that, then I can raise it to whatever the index is. Again, since this is a square root, we would be raising it to the second power. Remember, it's not always going to be that you're raising it to the second power. Refer back to your first example. This was the third root, so that's why we took that to the third power. These last two so far have been square roots. So in doing that, it cancels out the radical symbol, which means you're just working with 4x minus 3 equals -5 times -5 is a positive 25. Or you could plug that in your calculator. You would need to use your parentheses specifically on this one. This is why I say it's a good habit to be in, because if you type in -5 and square it, it's going to make it look like it's a -25, because that's reading the opposite of 5 squared. So that would be -25. When you squared this side, we're saying we're taking that number, -5, so you're taking the negative with it when you multiply it. So -5 times -5 is a positive 25. So that's an exponent rule that you need to be aware of. And the reason why you you need to use parentheses and take the negative with it as you're multiplying in an example like this. But why you would need to use a parentheses in your calculator so you can tell it that it's taking the negative with it in the multiplication. Then we would add 3 to both sides. So we have 4x equals 28. And then divide by 4, so x equals 7. So again, before we say, yeah, x equals 7, we need to go check. I guess I'm going to come to the left this time and check because I didn't leave space. Kind of like to separate it a little bit so I can see my work. So we have the square root of 4 times 7, that's a 4, it's an ugly 4, minus 3. And then I'm going to put a little on the ends just so I show that that radical is ending. And then I have plus 9 on the outside of the radical equals 4. Boy, my writing's not very good on that. I'm sorry. So we have second and 4 times 7 minus 3, and then make sure you arrow out from underneath the radical and then type in plus 4 if you're not doing the math yourself. And so that would be 9 equals 4, which is not a true statement. So again, that's because 4 times 7 was 28, minus 3 would be 25. So the square root of 25, square root of 25 is 5. What did I type in there? Oh, I put plus 4 instead of plus 9. So let's redo that, everybody. So 4 times 7 minus 3, and we are plus 9ing, not 4, would be 14. Okay, there we go. So if we were doing it by hand, again, 4 times 5 or 4 times 7 is 28, minus 3 is 25. The square root of 25 is 5 plus 9, and 5 plus 9 is 14, and 14 doesn't equal 4. So this one means this is not a solution. So this one would be said in WebAssign, you would write no solution, but it is technically called an extraneous solution. So even though we solved and we got x equals 7, it really didn't work out. It really isn't a real solution of that equation. Example 52. So example 52, the radical is not isolated yet, just like the other examples so far. So we want to move this one over by adding it. Since it was minus 1, we would have the plus 1. So the fifth root of 2 minus 15x equals 1 plus 1 is 2. So again, this would be an example where it's not a square root, it's a fifth root. So you want to raise it to the same power of the index. So you're raising it to the fifth power. By raising it to the fifth power, we're canceling out the radical. So I have 2 minus 15x equals 2 to the fifth is 32, or you can plug it in and check yourself in your calculator. 2 to the fifth is 32. Then we just solve for x. So we're subtracting 2 from both sides. So we have negative 15x equals 30. Divide by negative 15 and you will get x equals negative 2. So again, before we jump in and say, yeah, x equals negative 2, we have to verify that by checking to be sure it's not an extraneous solution. So we have 2 minus 15 times a negative 2 underneath that radical. Minus 1 equals 1. So we could plug that into our calculator. Since this is a fifth root, we have to type in 5 first, hit second and the x square root button, and it pulls it up as the fifth root. Type in 2 minus 15 times a negative 2, and then make sure you arrow out from underneath the radical and type in minus 1. And so when the calculator calculated all of that, it equaled 1. Again, it is okay to go ahead and do the math yourself. Negative times a negative would make that positive 30. So that's like saying the fifth root of 32 minus 1. We know the fifth root of 32 was, excuse me, 2 minus 1. And so 1, if you did it by hand. But you don't have to. It is a good thing to be able to, though, as well. So in all of these examples, so far we will turn the page and we have two more. But in all of these examples so far, we have done a really good job at isolating and raising it to a power and solving and always checking. When you get to this page, I guess there's just one example left. This is where you may have to do a little bit more work, and it's because if you notice on that other page, it always equaled just a number. It didn't equal like a binomial like this. So yes, that radical is isolated, but this isn't just one, it's x plus 1. So that is the difference between 53 compared to the ones before, 50, 49, 50, 51, and 52. All of these were just like equal 1 or equals 9 or equals -2 or equals 4. Just numbers, not like a binomial. So this is isolated, so we can go ahead and try to undo the radical by saying that's a square root, it's an implied 2, so we'd raise it to the second power. What happens though is when you come over here and square this, it's not quite as easy as if that was just a 1 to the second power. We have to FOIL this. We have to say x plus 1 times x plus 1. It's 2 parentheses, okay? Equals an x plus 3. So while we raise that to the other power to get rid of the radical, it made a binomial times a binomial. So we have to FOIL. So x times x is x squared. X times 1 is a positive 1x. 1 times x is a positive 1x, and 1 times 1 is a positive 1. And you can rewrite the other side if you wish. I like to go ahead and combine like terms on one side like we have in the past with equations before I start moving terms around. So 1 and 1 make 2x plus 1 equals x plus 3. So this is an example of a quadratic equation. Remember, quadratic equations have like an x squared in them. So because it's a quadratic equation, a reminder, we've done it a little bit in each topic, but a reminder is I can't just get x by itself because I have an x squared. So you have to factor to solve for your two solutions. How do I know there's two solutions? Because of the exponent 2. That's what makes it a quadratic equation. So we know we're going to have to factor to solve. So what that means is I have to get everything on the same side. I need to make just one polynomial. So I'd be subtracting x and subtracting 3 to zero out the right-hand side. And I chose to move everything to the left because my x squared is already on the left and it's already positive. So x squared, 2 minus 1 is a positive 1x, and 1 minus 3 is a negative 2. And so then we go through our rules of factoring. 1 times 2 is 2, and I know I'm using opposite signs to make a positive 1. If I have a negative 1 and a positive 2, that gives me a positive 1. So I'm going to split my x's apart, x and x, and plug those factors in, a minus 1 and a plus 2. So this is where I say x minus 1 equals 0 and x plus 2 equals 0, and I find my two solutions that I talked about above. So I would move 1 over, so since it's a minus 1, it would end up being a positive 1, and I would move my 2 over, subtracting, so that'd make it a negative 2. So x could equal 1 and or negative 2, but it's possible that one or both don't even work, or it's possible they both work. But we have to plug it into that original given equation, and I'm just going to rewrite it since we kind of have a lot of work that was kind of written over there to work with it at first. I just rewrote it. We're going to plug those values in. So like when x equaled 1, let's check it. 1 plus 1 equals the square root of 1 plus 3. Personally, I could do this a little bit quicker just by hand than using a calculator. So 1 plus 3 is the square root of 4, and 2, the square root of 4 equals 2. So we would say, yeah, that guy does work. So let's box it out. Let's check if -2 works. So -2 plus 1, so we're plugging it in for our x's, equals a -2 plus 3. So -2 plus 1 is a -1 equals -2 plus 3 is a +1. So it says -1 equals, and the square root of 1 is not going to be a -1. So it'd just be 1. So we would say, no, that was not a solution. So that one didn't work. So in this case, we wouldn't say 1 and no solution. We'd just say the solution to this equation is just x equals 1. That's different than because it was a quadratic and we had 2 to choose from. One was eliminated, but the other worked. Where this one only had one solution because it wasn't a quadratic, we did have to say no solution on that one.